All right, so our goal for this lesson is to multiply polynomials. So we've added and subtracted, and now we're going to talk about what do I do when I'm multiplying them. So this skill is really important because it's going to be super important later on in this module when we factor, and then also it's a very big skill in geometry and algebra too. It connects to the idea of distributive property, which you know about, the exponent rules, combining like terms, and it's also connected to adding and subtracting polynomials, which is what we just finished. So by the end of the lesson, you should be able to take problems like these and multiply them out. So when you stop and look at those 4 problems, what do you wonder about those problems? What questions pop up when you see these 4 problems? All right, so like I said, this is connected to the distributive property. So I'd like you to pause the video and I'd like you to try this first example on your own. So hopefully when you multiplied and distributed that 2 out, because it's 2 times this whole value, so that means everything is getting doubled. You should have ended up with 6x to the third minus 8x squared plus 6x minus 18, because I basically just doubled each term because I multiplied the whole thing by 2. All right, so when I jump down to this next one, I want to walk through this example and then I'm going to have you do the remaining ones. So same process, I'm going to distribute an x to each term, and so it's like a 1 is my coefficient, so 1 times 3 is just 3. Now if I have an x here, and I have 3 x's here, because I'm multiplying, I'm not combining like terms, I have 4 x's. So then I have a 1 times a negative 4, which is negative 4, and then x to the first times x to the second is x to the third. And then I have 1 times a positive 3, which is positive 3, and then x times x is x to the second. And then 1 times negative 9 is just negative 9, and then I have an x on my own. So that is the product of x and 3x to the third minus 4x squared plus 3x minus 9. So go ahead and pause the video, and I'd like you to try the 2 remaining problems on your own. Alright, so hopefully when you distributed that negative 2x to each term, you ended up with negative 8x to the fourth plus 2x to the third minus 10x squared plus 22x. So if you have any questions, make sure you write those down. And then in this example, hopefully you saw the difference. Here we're multiplying and here we're subtracting. So we're just subtracting each term. So if it was positive, when I subtract it, it becomes negative. When it's negative, it becomes positive. If it's positive, it becomes negative, and then I just combined my like terms. So I ended up with negative 2x squared plus 13x minus 13. So if you struggled with number 2 or number 3, then I'd like you to try these problems. If not, you can move on to the next segment. All right, so go ahead and check your answers if you needed to practice these and see how you did. If you struggled with number 4, you can go ahead and practice these problems just to check in on that skill. If not, go ahead and skip to the next section. So if you practice these, hopefully we got the same answers, but go ahead and look over my work and see how you did. Alright, so that was a review of some skills that we already have practiced that are going to be essential for you to understand how to do this lesson today. Alright, so I just want you to think about the word distribution and what that means to you. So go ahead and just jot down what distribution means to you, what you understand it to be, how do we use it in math. So one of the things that distribution to me that I think of is to pass out to all. So if I were to distribute candy to the class, I'm going to give everybody in the class 1 piece of candy, or I'm going to give everybody in the class 3 pieces of candy. But to distribute is to pass it out to all evenly. So I want you to think about this problem that we did earlier where we had 2 and we were multiplying the monomial 2, so the one term 2, by the polynomial 3x to the third minus 4x squared plus 3x minus 9. And I want you to think about our definition of taking one thing and passing it out to everything. What do you think we would do here? So how do you think? So up here we are multiplying one term, a monomial, by a polynomial. Now I have a binomial times a binomial. So how do you think we would approach this problem? Just take a pause for a second. So hopefully one of the things that jumped out at you is now instead of a 2 that gets distributed to everything because it's a monomial, I now have a 3x and I have a negative 4 that need to be distributed to each term in the other binomial. So that's where our first question is going to come from. What needs to be distributed? So in this case, the 3x needs to be distributed to each piece in the other term, and the negative 4 needs to be distributed to each piece in the other binomial. So what needs to be distributed? What terms need to be distributed to? And then do I have any like terms? So let's go ahead and do this problem. So the 3x needs to be distributed and the plus 6 needs to be distributed. And what do they need to be distributed to? Well, they both need to go to 2x minus 7, and then the 6 needs to go to 2x minus 7. So let's go ahead and do that math. So 3x times 2x is 6x squared, because I'm multiplying the bases. The x times x gives me x squared. And then 3x times negative 7 is negative 21x. And then 6 times 2 is 12x. And 6 times negative 7 is negative 42. And then do I have any like terms? Your middle terms will almost always be combined depending on what your binomials are. So I'm going to combine negative 21 plus 12, and that's going to give me a negative 9x, and then minus 42 because I can't combine any other term, and that's my answer. That's how we multiply. So the biggest thing with this is we need to make sure that everything from the first binomial is getting multiplied by everything in the second binomial, and then I combine my like terms. Alright, so in this example, 3x minus 4 times 2x plus 2, I want you to think about what needs to be distributed and what needs to be distributed to. So go ahead and identify those two pieces. So hopefully you were able to see that the 3x needs to get distributed to the 2x plus 2, and the negative 4 needs to get distributed to the 2x plus 2. Okay, so let's go ahead and multiply this out. So 3x times 2x is 6x squared, and 3x times positive 2 is a positive 6x. The negative 4 times 2x is negative 8x. Oops. And then the negative 4 times a positive 2 is negative 8. So when I multiply those out, I end up with 6x squared plus 6x, and then minus 8x minus 8. So then do I have any like terms? Well, my middle terms can be combined, and 6x minus 8x. So when I combine the like terms, I have 6x's and I take away 8, means I'm left with negative 2x's. And so remember, when we're combining our like terms, the variable doesn't change. Like term, like term, like term. It's when we multiply that our variable can change if I multiply a variable times a variable. So my answer to this is 6x squared minus 2x minus 8. Alright, so let's go ahead and try this example together. So what needs to be distributed? Well, my a and my plus 3. And what does it need to get distributed to? I need to do a times 2a and a times 1. So when there is no variable, remember it's like a coefficient of a 1. So I'm going to multiply a times 2a, and I get 2a squared, because 1 times 2 is 2, and a times a is a squared. And then I'm going to do 1a times 1, which is just 1a. And remember, if we don't need the coefficient, if it's a 1, we don't need to put it there. If you had plus 1a, it doesn't change anything. It just looks better. And then 3 times 2a is going to be 6a, and 3 times 1 is 3. And do I have any like terms? 1a and 6a make 7a. So my final answer is 2a squared plus 7a plus 3. All right, so let's go ahead and try this one as well, n minus 1 times n plus 1. And I want you to just pause the video for a second, and what do you notice about this one? Because this one's going to be a special case, and I just want to see, what do you notice about it? Is there anything that's interesting about this problem or unique? All right, so let's go ahead and multiply it out. So what needs to get distributed? The n and the negative 1. And what does it need to get distributed to? Well, I've got to do n times n, so that's just n squared, and n times 1, so that's plus n. And then I'm going to distribute a negative 1 to the n, so that's negative n, and negative 1 times negative 1 times the positive 1 is negative 1. And so, do I have any like terms? Well, n minus n just cancels. 1n minus 1n leaves me with n squared minus 1. So, earlier I said, what do you notice about this? And hopefully you noticed that these are literally the exact same binomials except for one is minus and one is plus. And so what we call this is a difference of squares. And so it's really important, and not right now, but as we do more and more and more of these multiplying, and then when we start factoring, it's important that you can recognize a difference of squares. So this is what's true about a difference of squares. A difference of squares is where the binomials are the same, except one is positive and one is negative. My pen's not working. One is plus and one is minus. And what's special about that is in the end, my final answer is just two terms because the middle term drops out. And the reason that it drops out is because I'm multiplying the exact same values, except for one ends up being plus that value and one ends up being minus that value, and those will always cancel. So I will always end up with a perfect square here, a perfect square here, and a minus sign in the middle. And that's why we call it a difference, that's the minus sign, of squares. Those are those two perfect squares that make up the first and last term. So that's not anything that you need to be aware of or familiar with right now, but I just want you to start seeing that because you're going to see a difference of squares a lot more. So this was a special situation. All right, so this one I have 3x minus 2, and I have that value squared. So I just want you to think about, what does squared mean, and how could I rewrite this so that it's a little bit more familiar for the types of problems that we're working on. So if you think about squared, if I told you what is 4 squared, well, 4 squared means 4 times 4, which is 16. So it means that base that many times. So the base in this case is 3x minus 2. So what that actually means is it actually means 3x minus 2 times 3x minus 2. Just like 4 squared meant base times itself that many times. So when I see that squared, I can rewrite it as the same binomial twice. All right, so go ahead and pause the video, and I'd like to see if you can multiply this binomial times itself, or a binomial squared out. All right, so hopefully you were able to come up with 9x squared minus 12x plus 4. So I want to bring this one up as well because this is a special situation that we call a binomial square. And what's special about a binomial squared, so you're going to start noticing some shortcuts. Just like the difference of squares, that middle term drops out, so once I start seeing that pattern, I don't have to do the multiplying all the way out. I start to recognize. So if you notice, my first term is 3x. And if you notice, the first term in the final answer is 9x squared. Well, 3x times 3x, or that first term squared, gives me 9x squared. And if you notice, the last term is negative 2. And if you notice, the last term of this binomial is positive 4 because negative 2 squared, that value squared, is negative 2 times negative 2, which is a positive 4. But that's where some students stop, is they just say 9x squared plus 4. Well, I have that whole middle term because it's not going to drop out because one's not positive and one's not negative. But if you notice, what happens when I multiply 3x times negative 2? I get negative 6x. But because I'm going to do that twice, I end up with 2 of those, which is negative 12x. So that's a shortcut. We're going to work on that a lot, so don't feel overwhelmed and think that you need to understand that. But we are going to start with talking about binomial squares and how there's a structure and a pattern to it that we can follow. All right, so now that you've gotten confident and comfortable with multiplying two binomials together, I'm going to throw a trick to you. And I'm going to say multiply this binomial by this trinomial. It's no different than what we've been doing. It's just a little bit bigger that I'm distributing to. So see if you can do this problem. So I'm going to go through those same questions. What do I need to distribute? So I need to distribute a 3x, and I need to distribute a negative 4. And what do I need to distribute to? Well, now instead of multiplying by 2 terms, I just need to distribute it to all 3 terms. So what is 3x times 2x squared? That is 6x to the third, because remember I have 3 times 2, which is 6, and x to the first times x to the second means I add them together, so I have 3 x's total because I'm multiplying. All right, and then I'm going to multiply 3x by negative 8x. And so 3 times negative 8 is negative 24. And then x times x is x squared. And then 3x times a positive 2 gives me a positive 6x. All right, and then the negative 4 I'm going to distribute to each piece. So negative 4 times 2x squared is negative 8x squared. And negative 4 times negative 8x is a positive 32x because negative 4 times negative 8. And then negative 4 times a positive 2 is negative 8. So then what are my like terms? Well, I don't have any other x to the thirds except for that 6x to the third. And then I have negative 24x squared minus 8x squared. And so I'm combining like terms. So they're both going to still be x squareds, but when I put them together, I have negative 32 because negative 24 minus 8. And then I've got a 6x and a positive 32x. So that gives me 38x. And then minus 8. So that is the answer. It looks a lot more complicated, but it's the exact same process. What needs to be distributed and what needs to be distributed to, and then combine my like terms. All right, so in this one, I'd like you to identify what needs to be distributed and what needs to be distributed to. So hopefully you saw that 3x needs to be distributed and a positive 6 needs to be distributed. And when I ask what needs to be distributed to, each one of these terms needs to get the 3x and each one needs the 6. So let's go ahead and do that now. So 3x times 2x to the third, so 3 times 2 is 6. X to the first times x to the third is x to the fourth. 3x times 3x. 3 times 3 is a positive 9. X times x is x squared. And then 3x times negative 7. 3 times negative 7 is negative 21, and there's no other x's. And then 6 times 2x to the third is a positive 12x to the third. 6 times 3x is a positive 18x. And 6 times negative 7 is negative 42. And then what are my like terms? I don't have any other x to the fourths. I don't have any other x to the thirds because we're going to put it in standard form. I don't have any other x to the seconds. However, I have a negative 21x and a positive 18x. So when I put those together, I get negative 3x because negative 21x's plus 18x's gives me negative 3. And then I have nothing to put that constant negative 42 with. So that is my answer. All right, so in this one, I've got a to the second that needs to get distributed, and I've got 3a that needs to get distributed, and I've got this whole trinomial over here that needs to be distributed too. So when I multiply a to the second times 2a to the third, I get 2a to the fifth, because 2 times the understood constant of a 1 is 2, and then a to the second times a to the third. When I'm multiplying, I add my exponents. And then I have a to the second times negative 6a, so that gives me negative 6a to the third. And then I have a to the second times 1 is just a to the second. All right, and then I'm going to distribute that 3a. So 3a times 2a to the third is 6a to the fourth. And then 3a times negative 6a is negative 18a to the second. And then 3a times 1 is 3a. And then I'm going to combine my like terms in standard form. So I don't have any other a to the fifths. I have an a to the fourth, but I don't have any to combine with. And then I have an a to the third, but I don't have any a to the thirds to combine with. I do have an a to the second minus 18 a to the second, so that gives me negative 17 a to the second, because a positive 1 minus 18 is negative 17. And then I have my plus 3a on the end. All right, so one of the things that you said to me is that you wanted some more practice. So the 6 remaining problems I'd like you to try on your own and see how you do. They're a review of the different types of problems that we've just seen. There is this box method. We're not going to do that because we're going to do the full-on distributing. So I don't want you to worry about the box method. Go ahead and just kind of ignore that, but go ahead and multiply them out just like I've been walking you through and see how you do. All right, so for this one, I got 6x to the second minus 10x plus 4. So if you didn't get that answer, make sure you look over my work and write down any questions that you have or any points of confusion. All right, so on this one, hopefully you got 5x squared plus 12x minus 32. All right, on this one, hopefully you got x squared plus 2x plus 1. All right, so for this one, hopefully you weren't tricked by the binomial times the trinomial and you ended up with 6x to the third minus 25x squared plus 8x plus 4. All right, on this one, you should have ended up with 4x to the sixth plus x to the fifth minus 3x to the fourth minus 8x squared minus 8x. All right, on this one, you should have ended up with negative 5x to the fifth plus 40x to the fourth plus 20x to the third plus 8x squared minus 64x minus 32. And what hopefully you noticed on this one is that there weren't any like terms to combine, and it was already in standard form, so I just made that my answer. All right, so we have done a ton of multiplying. So what I want you to do first is I want you to make a list of steps. So what's the first thing that we have to do? What's the second thing? What's the third thing if there's a fourth and a fifth? But what are the steps to multiplying two polynomials? All right, we are done with this lesson. What I'd like you to do is make sure you have an interaction in your notes. So what are things that you understand? What questions do you have? What examples do you want to talk about? What is still kind of confusing to you, but what do you need to talk about in your CSGs? And have a good day.